Hello and welcome to another session of AP Computer Science with the Arupe Virtual Learning Institute. My name is John Maxwell, and today we'll be going over a few things, including overloading methods, what happens when primitive data types and reference variables are sent into methods, what could happen. We'll also look at search algorithms in advance of what will be covered next week, both linear and binary search. And then finally, we'll introduce you to a class and talk about their role in communication within the software system. So let's start with what we have in front of us, and I'll just run it so you can get a sense of what it produces. To start off with on line 5, we create two int variables, a and b, and on line 6, two double variables, c and d. And we also create an array, which we'll be using later. And we'll point out on lines 8 and 9 they each call a method called sum. One method takes the two ints, and the other method takes the two doubles. And so what we'll do is we'll take a look down here at two methods that are named the same, sum, but have different types of parameters. And when a method has the same name but different type, number, or order of parameter defined within its parentheses, aka formal parameters, it is said to be overloaded. So let me say it more simply. When a method shares the same name as another method, the parameters have to have different order, type, or number of parameters, and that allows the compiler to know which method to use. So when it looks at this call up here, it'll say, aha, two ints, use the one that is specified to use two ints. When it looks at this method here, it will use the method that is requiring two doubles. Note that a method is not necessarily overloaded by return type. The fact that they have two different return types, an int and a double, doesn't matter. It again is only the number, order, and type of the formal parameters. So with that covered, I'm going to add a new wrinkle by uncommenting this and saying with A and D, which are int and double respectively, which method would it use? And let's run it and see. Well, it does run, and so it must use one method. And what happens here is A is widened. It's a widening conversion is what they call it. A is widened to a double. And so A, which is 5, becomes 5.0. And then the method with two doubles is called. Note that if you tried to narrow a double, a narrowing conversion, it wouldn't work unless you were doing casting. So while an int can be widened to a double cannot be narrowed to an int without a casting operation. So that's a little bit of a wrinkle. It returns to the idea that Java is a strongly typed language, meaning type is very important, in particular with accessing methods. And by the way, A and B up here are known as actual parameters here. A and B, C and D, A and D. These are actual parameters, what actually goes into the method, and these are known as formal parameters. So we want you to become aware of that terminology in case you see it on the test. Well, that's it about overloading methods. Repeating again, two methods or more that share the same name but different order, type, or number of parameters. So now we'll talk about parameter test, okay? And we'll send these values in, and I'm referring to A, B, C, D, and the nums array up here, okay, which will remind you is a reference type variable. A reference type variable, you can identify it, is typically created with the new keyword operator. And the reference is, of course, the location in memory. So take a look. We're sending in to before. Let me just run it and you'll see. Before, the cells contain A5 15.1 and the values are 2, 5, 6 in the array. Well, as soon as they come in, the actual parameters meet their aliases, which are the formal parameters. Nums becomes Z, and C becomes Y, and A becomes X. And we change X to 12 and Y to 3.7, and we set Z, our change, equal to Z, which is making each an alias of each other. And then we change the value at the 0 index. And you can see inside the parameter test method, the values are changed. 12, 3.7, and the values in the array are 1, 15, 5, and 16. However, after up here, the values for the primitive data types revert to their original number, 5 and 15.1 respectively. However, the array has the first element changed from 2 up here to 115. So let me summarize, and this is really going to occur with you on a multiple choice question. You'll absolutely see something like this. They want you to know it, because if you start programming without this knowledge, you'll really be, making errors. But they want you to know it. All parameters here are passed by value. But what is the value inside of A? It's 5. What is the value inside of C? 15.1. So they're not going to change. The value in A is copied over to X. The value in C is copied over to Y. And the value in nums is copied over to Z. However, what the value of nums is a memory address, which I've likened to the key to the house. If you have the memory address, you can make changes inside. And so that's exactly what happens. Keep in mind, okay, that primitive data types and reference types are handled differently. All parameters are passed by value. It's a question of what the values are. Primitive data types mean the value is the number in the case of int and double, and in the case of a reference type variable like an array, okay, the value is the memory address. Now the exception I'll mention is a string, which is an immutable class, okay? So immutable means that, like, even though it's a reference object, it cannot be changed in the way that we've just changed the array. So concluding on this topic, I'm going to pull back and tell you that, like, programming is about the communication within the software system. And what we've learned is in comes information to methods via parameters, and out goes information via a return type like int, double, or void. Okay, and in a void there's no return information, but it's an input output model. In come parameters, out comes the return type. And that is consistently and constantly going on in a software system, where one part of the software system is calling another method and sending information to be processed and perhaps via return type being returned. So being aware that particularly in object-oriented programming, it's about the communication. Now, I briefly went over a quick thing last night, okay? And I want to point out here, I'll run this one here called string array. Created a string array called words that contains hello, everybody, one, and the exclamation point. And I output the indices 1 or 0, 1, and 3. And I get hello, everybody, skipping by the indice 2, the index 2. Well, I want to point out this type of syntax. The object inside the array position, or each array position, but in particularly array position 1, index 1, is a string. And so that index can call any one of the string methods. And I do that here. And what I do is I say hello every and then drop body and add 1. And it's a little trick, right? But obviously what I want to draw forward is the idea that if an array contains a reference type variable, particularly with methods like the string class has methods, then that particular index can call any one of the methods. Okay, it's not like a static method that's called by the class name. It's called by an instance of the, in this case, string class, and word square brace 1 is an instance of the string class. That's the way the compiler regards it. So moving a bit to what we covered last night, okay, we talked about searching. What good is storing information in a collection like an array if you can't retrieve information from it? If I can't look up in my student system your record and be able to review it and find it easily, then like the system is not worth anything, because it may contain information but it can't be found. All right, it's like a library without a card catalog. So let me just run this one here and say enter a number you want to find. And so I'm searching for values within this array, and I'll start off with 15 because I can see it's in the array. And it says, wow, you found it at index 3. Okay, and I'll show you how that worked. Okay, but what we did is use something called binary search, and I want to describe that. In comes the array and the target that I want to find, 15, and it'll search and return the index where it's located. Now, the way the method works, if the index is greater than or equal to 0, meaning it's in the array, okay, then it's been found. Else, if it happens to be -1, I happen to know that, then it's not found. So it's not greater than or equal to 0. And then I ask again, would you like to try again? And I hit Y and enter a number. I'll put one that isn't in the array, 43, hopefully. And it says 43 not found. And then I'll type no and stop that. But notice, okay, a little trick with the scanner. I like the idea of while response equals yes. Note I use the string method equals to evaluate Y. I would avoid equal equal. It worked once but not twice, okay, for me, so I went to equals and it fixed. But what happens is that it takes in an int here called target and leaves the carriage return, the thing that you do when you hit enter. That's called a carriage return. So I want to consume that carriage return through scan.nextLine, ordinarily used to capture an entire line of string content. before I ask for the response, which is yes or no, y or n. Okay, so there's an example of using a while loop, and some of you have begun to use them in testing your program. It can be very useful with a simple user indeterminate loop like a while loop that asks the user, hey, would you like to continue? Okay, and so now we're going to cut away and look at binary search. So I asked a question, you know, what do you know about binary search? And someone said, it's got to be sorted. The information has got to be sorted. And indeed, it is sorted right here. 1, 5, 7, 15, 38, 57, 61. You'll notice it's moving in ascending order. So it is sorted. And that's a precondition for binary search. And let's look at it from there. Now notice it's called by search binary search. So here is one file asking another file to run a method, okay, inside of it called binary search with these two parameters. So somehow the information is going from here to here. This is known as a tester or driver file, and we'll look at now search. All right. Well, here comes the key, which is also known as target in the other program, and the array called numbers. And while they may have different actual names as actual parameters in the formal sense, as formal parameters, nums becomes numbers and target becomes key. So the lowest index is 0 and the highest index is numbers.length minus 1. So I have the low and the high indices, and the middle is low plus I divided by 2. And if that's not equal to key, and low remains less than high, because if it's not found, low becomes higher than high, and the algorithm will stop. But as long as you haven't found the key, if key is less than the number in the middle, then move high down to one less than the middle. And if the key is greater than the number in the middle, then move low up. And then in each case, recalculate middle. And keep on going while the number is not found, is not equal to key. And as we move high up, it'll, if it's not found, or low up and high down, if it's not found, they'll eventually cross each other. Okay? And then when this loop stops, if number in the middle equal key, we'll return the middle, and else number one's negative 1. So let's break this down. Okay, we have one program, search tester, calling another program, search.java, because they're static methods in search.java. There's no main, just a class with static methods. Okay. And binary search works by successively dividing the array in half. So if I had numbers 1 through 100, the first guess would be 50, and I would say too low. And then the next guess would be 75, and I would say too low. And then the next guess is 87. And what I'm doing is just dividing the remaining values in half. Low plus high, right, is what they say, divided by 2. Eventually I'll get to 93, and maybe what happens is I can usually solve that in 6 or 7 steps. If it's not found, I think it's 7. But as the sample size goes up, I use the one of like 100 values. If you had 1,000, you know, it would go up a little bit, but not as many operations as you think. 1,000 divided by 2 is 500. Divide that by 2, 250. Let's say it's lower, then you go into that 125, and then you could go to 175. You see, that it really wouldn't take too many steps to either not find or find the value that you're looking at. They call that log n performance, logarithmic performance. Okay, so I want to say binary search is very good. You may want to ask yourself, hey, do I have to memorize this code? Do I have to be able to write it? No. But like the multiple choice questions will ask, hey, take a look at this binary search method. It doesn't always work as intended. What's wrong? Change which line in order to make it work. Okay. I want you to notice that anything divided by 2 when we're talking about integers is integer division. So if you get to a number like 13 divided by 2, the answer is 6. Integer division, upside the head. There you go. You never know where it's going to get you. But, okay, it's very efficient. All right. And what's a poor boy or girl to do, right, if the array is not sorted? And it's called linear search, and it's just a line from beginning to end. It's sometimes called sequential search. You just start at the beginning and going, is it this one? 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 It's like the kid in the back seat of the car going, are we there? Are we there? Are we there? Are we there? Okay, I know that you're not parents yet, and I hope you never did it to yours, but like, seriously, must we go through 100 elements of a 100 element array in order to find out that it's not there and return -1? Could be that's the worst case. But of course, I asked about the best case, and somebody said, hey, it's right in the middle. And then I said, like, Mama, it could be in the middle on the binary search. It could be like linear search, it could be right in the first element. Well, it could be in the middle element of binary search, so that's not better. But somebody came up with the right answer, which is that if it just has a few elements, 2 or 3, okay, the idea of going and doing a binary search is actually a little bit excessive. So linear search works when it's not sorted. All right, so that is something to consider. Now I'm just quickly going through this next point. I created this point class, and we're going to see it again. And I said, hey, what's a point? It's really an x and a y. Isn't that what it is in math? Here, the Cartesian plane, x and y are points, okay, in math, all right? And here are two methods that create points. Again, overloaded, they share the same name, by the way, as the class, and they have 2 ways of creating a point. One using 2 doubles and the other using 2 ints, okay? And then here, outside the class, and there's no main method here, this is for classes that want to have use of a reference type called point. You have a get x and a get y. So if you want to ask, hey, what's your point x? What's your point y? You could use the get x and get y methods. These are called accessors. And if you wanted to change a point, you could use set x and set y. And why? Because these are private. They don't allow outside access to these class instance variables. So you have getters and setters here, accessors and modifiers to be able to access the private data contained in the point class. So we also have a toString, which is how to represent itself outside the class. The toString method is automatically called when you use systemout.println, okay? And that's why when you just put the array name in systemout.println, it just outputs the memory address, okay? Because it doesn't have a toString method. And there's a way of comparing points. If my x is equal to your x and my y is equal to your y, okay, then we're the same point. Well, look at the point tester again outside the class. Create a couple points here, point P1, point P2, point P3, and then I can test them out. P1.setY, P1.getX and getY, and then P2, and then comparing the two of them. And they're not the same points, okay, because they don't have the same X and Y. So here's another facet of communication, all right? What happens is we have a class here called point, and it could be part of a larger software system. You know, for example, an airplane has a throttle class, and it has a landing gear class, and it has a jet engine class. And what happens is the throttle class could send in a request. Well, you create a throttle, you create an engine, you create landing gear in a program that contains a main. And then what happens is the throttle object can call the engine object to slow down or speed up. And through the integration of classes, we also open another dimension of communication within the software system. You don't have to worry about this concept yet, but it's where we're going. It's what Java is famous for. It's object-oriented programming, and it's coming to you next semester. So take a look at these files. I hope they make sense to you, and reach out if you have any questions. Thank you for watching.